Alright, so here we have our senior project. This is the prototype board we built for it. You can see a little LED blinking, that's for the Bluetooth connection, and I'm just going to talk about the different parts of the project. So first off, right here we have our connectors. Right now it's plugged into a wall wart, but when in-car usage is going on, it'll be plugged into the D-sub port, which then connects to the obd cable. Next to that over here in this area is our CAN transceiver, which is responsible for communicating with CAN, which is one of the obd protocols, sponsored, or not sponsored, but legislated. Right here we have our Bluetooth circuitry. This is the Bluetooth chip. This little blue part's the antenna for it. Little LED to indicate what's going on with the Bluetooth. That just means that it's actively able to have a connection, and Schuyler is going to connect to make it so you can see what it looks like. Okay, so now you see the blue light's gone off and there's a red LED lit up. That's indication that we've paired with the device successfully over some form of encryption as well. Alright, so going to the center, this chip right here is the main chip responsible for everything. It's a PIC chip with the STN built into it. And it's basically responsible for sending out digital signals and receiving digital signals and processing them. And this chip is how we can get our protocols sent over Bluetooth. Going up here, we have a few different protocols. Over here, we have the keyword protocol, these two main resistors, and some other associated stuff. These two main resistors are responsible for two different protocols. They use the same physical layer. Those are ISO 9141-2 and the keyword protocol. And then this section right up here is the last of our two protocols, which are VPW and PWM, which are used in Ford and GM respectively, which make out the 5 protocols. Furthermore, up here you see our power circuitry. It's basically a 12 to 5 and 3.3 volt regulators, as well as some other stuff going on. So this main guy is the 12 to 5 volt linear regulator, and then this is the 3.3 regulator. Here's a variable regulator that we need for the PWM and VPW circuitry, and here's a gate to control what the voltage is of that variable regulator. So that's a little overview of all of the circuitry involved, just so you have some sort of idea of what it physically looks like now. All the parts were chosen to be downsized. We just wanted to build it on a breadboard as a prototype.
So the second part of our project is the Android app. This is the Android app here that we've been writing. So you open it up, and if Bluetooth already hadn't been enabled, it would have asked me, do I want to enable Bluetooth? So then it goes through all of the different Bluetooth devices I've already paired with. So I'm going to select obd Bluetooth because that's the board. Alright, you can see here this is an example of one of the features. Basically, if an exception is thrown, it shows you the exception here, and it tells you the reason, and it doesn't kill the app. Let me try it again. There we go. Alright, so this time it worked. It says Bluetooth connected, it's ready to download codes. So you go up here, and you hit get codes, and it'll do some work. And let's see. So it successfully read the codes. This car happens to have no codes. And you see here the MIL status is off because in this car the check engine light, which is officially known as the malfunction indicator light, is off. And so it's working. This is Torque. This is an app that's available for purchase that also talks to this class of OBD reader chips. This is just for demonstration. The hardware on our project also has the ability to read real-time information from cars that support it. This car happens to support it. You can see here that it's currently showing the revs that the car is, it's basically what the car is running at currently. It can do some other stuff, like let's see what other real-time information it has. Let's see. Some more revs, I guess. Oh yeah, it also shows here. So it shows the throttle position, the vacuum in inches of mercury, the coolant temperature, and the speed. And then if you look down here, you can see that this is the send and receive light from the STN to the Bluetooth, and you can see it's constantly outputting the information for the real-time information on this app. So these are just showing some available sensors that this particular car has. It has a ton of different sensors, and these are all different things you can read. So as just sampling, it has like everything from fuel system status, coolant temperature, fuel trim, oxygen sensors, catalyst temperature, fuel level, absolute load, accelerator position, time run with the check engine light on, so you could tell if, say, you were buying a used car and it had the check engine light on, you'd be able to read it, and you could see, oh, this person's been running this car with a check engine light for a year. Probably means they don't keep up on their maintenance. So you know, this chip definitely has a lot of features. It's really useful for you know, getting a lot of information from different cars. Okay, so now we're in a different car. We have the project set up again. The Bluetooth's connected, it's ready to go. And this is to demonstrate both. This car has a different protocol. It's older. It's the, what is it? The keyword. It's the keyword protocol. The other car that we just showed you was CAN, which is a much newer and higher speed protocol. So this is to demonstrate that they both work. And then we'll go and scan codes on this car. Okay, so the check engine light is also off on this car, but this car has one code, P0420, which says the catalyst system efficiency is below threshold on bank 1. So this is like a standard trouble code that cars will get, because one of the main points of the OBD system is to show that, is to do emissions testing. And so like catalyst system, which is basically the system that cleans your exhaust before it actually goes out into the world. If its efficiency is below threshold, this car is putting out more emissions than it should be. So it's, you know, good to know.